Good day, everyone. Our learning competencies for today is all about theorems on secant, tangent, and segments of a circle. I am Gerardo Viduya, teacher of Ordineta City National High School. Before we proceed, let us know first the theorems of secant, tangents, and segments of a circle. Theorem A: the measure of an angle formed is one-half the positive difference of the measure of the intercepted arcs. If 1. 2 secants intersect in the exterior of the circle. 2. If a secant and tangent intersect in the exterior of a circle. And 3. If two tangents intersect in the exterior of the circle. Theorem B: the measure of the angle formed by two secants intersecting in the interior of the circle is one-half the sum of the measures of the intercepted arcs by the angle and its vertical angle. Theorem C: the angle formed by the intersection of a secant and a tangent at the point of tangency is one-half the measure of the intercepted arc. Okay. We have the activity 1. We are using the figure where the name of a circle is circle F. So we can name the circle by its center. Now, two secant line intersect in the exterior of a circle, where line segment AC is a secant line, line segment EC is also a secant line, and AE is the larger arc, and BD is the smaller arc. The point of intersection of two secant line is point C. So here, two secant lines intersect outside the circle. In the given figure, if the measure of arc AE is equal to 128 degrees, which is the larger arc, and the measure of arc BD is equal to 49 degrees, which is the smaller arc, what is the measure of angle ACE? So using your theorem A, where two secant intersect in the exterior of the circle, the measure of an angle formed is one-half the positive difference of the measure of the intercepted arc. So using this theorem, the measure of angle ACE is equal to one-half the positive difference of the measure of the larger and the smaller arc. So by simplifying, we have now then one-half of 70 degrees, then the measure of angle ACE is equal to 38 and 5/10 degrees. Example number 2. Using a figure of a circle, the name of the circle is circle J, where two tangents intersecting in the exterior of a circle. So, line segment BE is a tangent line, line segment CE is a tangent line. Arc BFC is the larger arc, and CB is the smaller arc. So the point of intersection of two tangent line is point. Theorem number 2, if two tangents intersect in the exterior of a circle, the measure of the angle formed is 1/2 the positive difference of the measure of the intercepted arc. Okay. So the measure of angle BEE is equal to 1/2 the positive difference of the larger arc and the smaller arc. So by simplifying, 1/2 of the positive difference of 206 degrees and 154 degrees is equal to 24 degrees. That is the measure of the angle BEC. Okay, next, circle M, where a secant and a tangent intersect at the point of tangent C. So CD is a secant line, and DE is also a tangent line. So the arc CD is the arc intercepted by angle CDE. Okay, for example, if the measure of arc CD is equal to 140 degrees, so using your theorem C, the angle formed by the intersection of a secant and a tangent is 1/2 the measure of the intercepted arc. So by simplifying, the measure of CDE is equal to 1/2 the measure of the intercepted arc. So 1/2 of 140 degrees is equal to 70 degrees. Okay, next. Activity 3. Using again the figure, which is formed by two secants intersecting in the interior of a circle. Interior means is inside the circle. So line segment EF is a secant line. Line segment CD is also a secant line. Arc AC is the arc intercepted by angle ABC. Arc DF is the arc intercepted by angle DBF. So the point of intersection of the two secant line in the exterior of the circle is point C. So interior means inside the circle. Okay, example, if the measure of arc AC is equal to 82 degrees and the measure of arc DF is equal to 50 degrees, then what are the measures of angle ABC, the angle DBF, and angle CBF? We say that the measure of angle DBF is equal to the measure of angle ABC because they are vertical angle. So thus, using your theorem B, the measure of the angle formed by two secants intersecting in the interior of a circle is 1/2 the sum of the measure of the intercepted arcs by the angle and its vertical angle. So, if the measure of angle DBF is equal to the measure of angle ABC, then it is equal to 1/2 the sum of the measure of AC and the measure of DF. So by simplification, we have now 1/2 the sum of 82 degrees and 50 degrees is equal now to 1/2 of 132 degrees. The measure of angle DBF is equal to the measure of angle ABC. It's equal to 66 degrees. Since angle DBF and angle CBF form a linear function, we have the measure of angle CBF is equal to 180 degrees minus the measure of angle DBF. So since the measure of angle DBF is equal to 66, so 180 degrees minus 66 degrees is equal to 114 degrees. So therefore, the measure of angle CBF is equal to 114 degrees. That ends my discussion for today. Thank you and stay tuned for the next virtual instruction.